All right, so let's go ahead and take a look at this one now, guys. It says find one value of x that is a solution to the equation. Once again, we're focused on finding for one value of x. Now, on this one, guys, notice that they're not actually telling us let a certain variable equal something. Now, for this one, we do have to make up our own variable, and we have to see what it's going to be equal to. So I'm going to go ahead and say let, I don't know, let's use p equals. Now, what is p going to equal in this case? In this case, I am going to be focused on that expression there. 5x plus 2. I want to go ahead and replace that p with that 5x plus 2. 5x plus 2. So from there, we actually need to substitute for p, right? We're solving for p. But notice in this case, guys, this expression is not written as 5x plus 2. So I do want to go ahead and focus on finding the GCF of that expression there. Let's go ahead and find the GCF of this one. And GCF in this case, biggest number that divides into 15 and 6 is 3. So let's go ahead and rewrite the equation. It's a 5x plus 2 squared plus 3, open parentheses. If you factor out a 3 from 15x, you have a 5x left. And if you factor out a 3 from a 6, you have a 2 left. All right, we did say that expression is going to be p. So then that's going to now become p squared plus 3p equals 0, right? Now, this is very different from the other ones we had worked, for examples 3 and 4. On this one, we are going to be doing a different type of factoring, which is actually just a GCF. So this one, we have to do GCF factoring. So if we take a look at this expression here, what's the biggest number I could divide, or what can I factor out from them? And it's not really a number, it's a variable. I need to factor out a p from both of them. So if we factor that out, I have a p on the outside. Now if you factor out a p from a p squared, you only have one p left. And if you factor out a p from a 3p, you have a 3 left. All right. From there, we're going to go ahead and make each of the expressions equal to 0. And in this case, the values for p is 0 and negative 3. Now, this is not what we're looking for, because we're actually looking to solve for x here. So once we got that solution here, now we want to go ahead and make either of these equal to this initial part, equal to this part here, to this one here. So let's go ahead and do that. That would actually be the last step. So because we said let p equal a 5x plus 2, I'm going to go ahead and make it equal to either of these. And let's say I want to go ahead and work with the 0. P equals 0. So then that's going to become a 5x plus 2 equals 0. Let's go ahead and leave the x alone. So let's subtract 2 to both sides. And I have a 5x equals a negative 2. From there, let's go ahead and divide both sides by a 5. Both sides by a 5. And x in this case is going to equal negative 2 over 5. And if we check if we can simplify this, we can. So that's actually one of our solutions. I could try with the next one with the negative 3. So it's written in blue. P equals negative 3. And that becomes 5x plus 2 equals a negative 3. So let's go ahead and subtract 2 to both sides. Subtract 2. And I have a 5x equals a negative 5. So then from there, last step is to divide by a 5 on both sides. And x in this case equals a negative 1. So I could input either of these as my solution. I'm actually going to try to input the fraction just because that seems like the most difficult answer in this case as compared to the whole number. But let's go ahead and check. And that was negative 5 over 2? Or negative 2 over 5? I think it was negative 2 over 5. Let's see. And we got that correct. And you could actually check the steps in this case, guys. Check the steps. We are going to make the expression equal to what's in the parentheses. And then we got the same p-values. We make them equal to each other, and we solve for the x. So that is our solution.